So I'm going to be solving a problem using the partial sum method. The equation that I decided on was 25 plus 56. The first thing I'm going to do is identify the number placements. We don't have a 100s column, there's nothing in it, so we only have a ones column and a tens column. I'm going to start on the tens column, and my color is going to be blue. I'm going to circle the numbers that are in the tens column. The reason, because 10 ends in a 0, we're going to add a 0 to our tens column to make our numbers 20 and 50. We're going to add these together, but that's why I add a 0, because it's in the tens place. So 50 plus 20, obviously, there's nothing to add in the 0 place, but in the tens place, 5 plus 2 is 7, so we would get 70 for the tens place. Now we're going to move on to the ones place. I'm going to circle this in green. This is just a good identifier, I feel like. So 5 plus 6 is 11. We're not going to add anything because it's in the ones column, so it would literally be 5 plus 7. That would give us 11. Now over here, separately, what I like to do is make it another mini equation. So 70 plus 11 would simply, there's nothing to add to the 1, so we would get 1, and 7 plus 1 is 8. So the sum to our equation is 81, but this is the partial sum method. I like this method simply because for early education math, I feel like it's extremely important to understand the basics of math, and with this method you can identify not only like number placement, you can also use color coordinating to draw attention to the equation. For example, I did blue for the tens column and green for the ones column, and I did the whole equation in blue and the whole equation in green. I made it purple and I circled the sum with red because I just felt like the sum is red, and I don't know, teachers just use it and it makes sense. But that is how I did the partial sum method.